Good morning, viewers. This is Kasturi Day. Today, I'll discuss the different types of elements. According to the periodic table, that is representative elements, transition elements, inner transition elements, and noble gases, which I told you this classification discussed in my last video. So we will continue with that. Uh, with that classification, that is with these types of elements. So we will start with this discussion. Before that, I will request you to please to subscribe my channel. If you have not subscribed yet, and please ring the notification bell because that will notify you as soon as a new video is uploaded. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And also do meditate before you start your day. So we will also start with the meditation for just 1 minute. Let us, let us concentrate on the point of light. Okay. So think that point of light is in front of you, and that light is falling on you. Your whole body is being lighted up. You're feeling energized, feeling very enthusiastic. You're feeling happy and enjoying your work, which you are doing and will do later on in the day. You're getting interest in whatever job you're doing, and very successfully you are completing that at the end of the day. And at the end of the day, you are thanking God for giving you such energy, such power, such enthusiasm, and also happiness and joy. Okay. So we will stop here and continue with the discussion. Okay. So today we'll start with the representative elements. This is the chapter of the periodic table according to ICSE syllabus class 9. Okay. And the links of my last video and the other chapter links, the other playlist links of the other subjects. That is, this is the chemistry chapter I'm discussing, the physics and also the biology chapter link, playlist links are there. You can, even the chemistry playlist link is also there. Okay, you can refer to them, and that will help you in navigating, you getting the playlist and getting the chapters where they are. Okay. So you can very easily go to the chapter which you want to see, the videos which you want to see. Okay. And also the previous video, which is there, first, second, and third videos, that will also be there in the of this chapter. That will also, the links will also be there in the description box. Please find it out. Okay. And if you, again, still, if you have any problem, you can write in the comment box, and also you can refer to my email ID, that is kasturi74@gmail.com, KASTURI kasturi74@gmail.com. Okay. So let's start with the discussion, that is representative elements. So what are representative elements? The elements of the group 1 and group 2 and the elements from group 13 to group 18 of the periodic table belong to this type. Okay, we know there are 18 groups in total. Okay, so that is 8 groups, 1 to 7 group. These are subdivided into subgroups, and the group number 8 group is singular group without any subdivisions. So all the groups counted together will give you group 18, till group 18, from group 1 to group 18. Out of this, group 1 and group 2 elements, and also group elements of group 13 to group 18 of the periodic table, they belong to this representative type of element, representative elements. Okay. Or you can say the S block and the P block elements are collectively known as representative elements. Okay. Now, there are orbitals we know SP, okay, SP, D, and F. 4 orbitals are there, S, P, D, F. So there will be the S and P orbitals are elements, the elements of S and P block elements, those are representative elements. Okay. In these elements, the S and P orbitals are incomplete. Okay. So they are called representative elements. Why? Because they display a wide range of physical and chemical properties. Also, they represent the elements of that group. That's why they are representative elements. Okay. Both the S and P blocks are collectively known as representative elements, as the chemically very reactive metals and non-metals and can easily attain the nearest noble gas configuration by either losing or by gaining electrons from their valence shell. Okay. So these S and P block elements are known as representative elements for 2-3 reasons. One is they display a wide range of physical and chemical properties. They are chemically very reactive metals and non-metals. They can easily attain the nearest noble gas configuration by either losing or gaining electrons from their valence shell. Gaining electrons to their valence shell or by losing their electrons from their valence shell. Okay. So another name of representative elements are group A elements or the main group elements. Okay. Group A elements or main group elements. Okay. Next, we move on to the next point. See, group 1, or you can say S block element. These elements are also known as alkali metals. Okay, why? Because their oxides, the metals, these are metals. So these metals, when they combine with any oxygen, when they combine with oxygen, or when they combine with oxygen forming their oxides, these oxides, when dissolved in water, they form alkalis, except hydrogen. Hydrogen does not form alkali, it's water. Hydrogen combining with oxygen, it forms the water. Again, so hydrogen does not form the alkali, but the other metal, and even hydrogen is not a metal. Okay, so the alkali metals, their oxides with water form alkalis. So these metals, these elements of this group, that is alkali metals, they form S block elements. They are metallic in nature and they tend to form ionic bonds. How they form ionic bonds? By losing one valence electron. Okay, that's why they are placed in group 1. Okay, so they lose one valence electron to form an ionic bond. Okay, that is, the examples of the elements of this group are lithium, sodium, potassium, rubidium, and cesium. Okay. Now we come to group 2. These are also S block elements. They are also known as alkaline earth metals. Okay. The first group, that is group 1, that is alkali metals. Group 2 are alkaline earth metals. Why? Because as their oxides form weaker alkalis than 1A elements and are mainly found in the Earth's crust. They are generally found in the Earth's crust. With water, they also form alkalis, but weaker alkalis than the group 1A elements. Okay, why A? Because all these groups, that is group 1, group 2, group 13, group 14, 15, 16, 17, and 18, these all are group A elements. Okay, previously I told you in the last point, I told you that it's a group A elements. These all are group A elements. Okay, so that is why the first group, that is alkali metals, are group 1A elements. Okay, So these form, or these also group 1A elements also form oxides, which are when dissolved in water, they form alkalis, but stronger alkalis than group 2A elements. These form weaker alkalis with water. Okay, their oxides form weaker alkalis with water. And they are found mainly in the Earth's crust. They are also metallic in nature, and they tend to form ionic bond by losing by losing two valence electrons. That's why they are placed in group 2 elements. Okay, so they lose two valence electrons, whereas in case of group 1A, they lose only one electron from their valence shell. Okay, example of this group elements are beryllium, magnesium, calcium, strontium, and barium. Clear? Next, we move on to group 13 or P block elements. These are also called boron family. Okay, as it is the first member of the group. As boron is the first member of the group, that's why group 13A elements are known as what? Boron family. Okay, they are also metallic elements, and with some of them are metalloids also, having what type of properties these metalloids have. They have both the properties, that is metals and non-metals properties, that is they are intermediate between the metals and non-metals. The properties are intermediate between the metal and non-metals. Okay, here boron is a metalloid while all the other elements are metals. Okay, of the group 13 elements, boron is the first member of the group. That's why this group is named as boron family. They are metals, metallic elements, as well as metalloid elements are there. Metalloid elements, they have the properties of both metals and non-metals mixed together. That is, they have intermediate properties of metals and non-metals. Boron is a metalloid, while other elements of these group are metals. Clear? Next, we move on to group 14. That is, these are also P block elements. And this element, these elements of this group, the elements of these group are known as carbon family. Okay. Why? Because carbon is the first member of this group. Here, elements are mixture of non-metallic and metallic characters. Okay. Even some metalloids are also there. So, all the three types of elements are found here in this group, in this family, that is metallic, non-metallic, as well as metalloids. Okay. Now, carbon is a non-metal of this group, with silicon and germanium are metalloids, whereas lead and tin, they are metallic elements. Okay. Lead and tin, they are metallic. Silicon and germanium are metalloids, and carbon is a non-metal. So all the three types of elements are found here in this family. Okay, they have 4 electrons in their valence shell, and they tend to accept 4 electrons to form the octet. Here they accept 4 electrons to form the octet. Clear? Sorry. I'm sorry. Okay. Next, we move on to group 15 block elements. 15 P block. This is also a P block element. Group 15. Here, it is the nitrogen family. Group 15 is known as nitrogen family because nitrogen is the first member of this group. Here, in this group, in this family, mixture of non-metallic and metallic elements are there. Even metalloids are also there. Whereas here, the nitrogen and phosphorus are non-metals. Okay, arsenic and antimony are metalloids, whereas bismuth is a metallic element. Okay, so nitrogen and phosphorus, these are non-metals. Arsenic and antimony, they are metalloids, whereas bismuth is a metallic element. They have 5 electrons in their valence shell, and they tend to accept 3 electrons to complete their octet. Clear? Now we move on to group number 16, that is also a P block element, and we call it as, it's also named as oxygen family. Why? Because oxygen being the first member of this group. Okay. It consists of non-metals, metals, and metalloids as the other members of this group, family. Okay. So, of this representative elements group. Okay. So here oxygen, sulfur, and selenium. Oxygen, sulfur, and selenium are non-metals, whereas tellurium is a metalloid and polonium is a metallic element. See, oxygen, sulfur, and selenium are non-metals. Tellurium is a metalloid and polonium is a metallic element of this group. Here, there are 6 valence electrons and they tend to accept 2 electrons to form their octet. Okay. Now, group number 17. Group number 17 is known as halogens. Okay. And as they form salts, that's why they are known as halogens. And all the elements of these groups are non-metals. See, as we, just a second. See, just see, group number 13, there is only one non-metal. Sorry. Boron is a metalloid and all are metals, okay? There's no non-metal. Group number 14, carbon is the only non-metal, whereas selenium and germanium, those are metalloids, and lead and tin are metallic. So 2 metalloids and 2 metallic, 1 non-metal. Group number 13, no non-metal. Metalloid and all other are metals. Okay. Now as we move on to group number 15, we see 2 are non-metals. Nitrogen and phosphorus, those are non-metals. 2 are metalloids and 1 is a metallic element. This one. As we move on to group number 16, we see that is in the oxygen family, we see 3 are non-metals. That is oxygen, sulfur, and selenium are non-metals. Tellurium is a metalloid, that is 1 is metalloid and 1 is metallic. Clear? Then as we move on to group number 17, here all are non-metals. Okay, that is fluorine, chlorine, bromine, iodine, astatine. All those are non-metals. No metals, no metalloids. Clear? So group number 17, all are non-metals. As why they are known as halogens? Because they form salt. And they have 7 electrons in their valence shell and they tend to accept only 1 electron to form their octet. Clear? Next is just this is the flow chart. You can see. See group number 1, this is known as alkali metals and these are S block elements. Group 2, these are alkaline earth metals. These are S block elements. Group 13 is the boron family. These are P block elements and have 3 valence electrons. Excuse me. Then group 14, they are P block elements and they have 4 valence electrons. So group 1, they have only 1 valence electron in their valence shell. They tend to lose that to form the octet. Group 2, it has 2 valence electrons and they tend to lose those 2 to form the octet. Group 13 has 3 valence electrons and they also tend to lose those 3 electrons to form the octet. And group 14, these are 4 valence electrons. They tend to accept 4 electrons to form the octet. Then group number 15, they are also P block elements and these are nitrogen family. They have 5 valence electrons and they tend to accept 3 electrons to form the octet. Group number 16, that is the oxygen family and they are also P block elements. They have 6 valence electrons. They tend to accept 2 more electrons to form the octet. Group number 17 is the halogen family. They have 7 valence electrons. They tend to accept only 1 electron to form the octet. Okay. So just see here also there's a chart. You can see this is the representative elements. You can see the periodic table where these elements are found. So group 1, this is the first group. This is the second group. Okay, and this is the group number 13 to group number 18. Okay, that is the boron family, carbon family, nitrogen family, oxygen family, halogen, and group number 18 is also present in the this one representative elements. These are the noble gases, but this is not present in the representative elements. This is group number 18. Okay. Separately, you will find in the we will discuss separately at the noble gases also. Okay, so these are the representative elements which are found in the periodic table. Next, we move on to the transition elements. Oh, next, let us discuss some of the general characteristics of these representative elements. So mainly they include both metals and non-metals with regular gradation from metallic to non-metallic character as one moves from left to right. That is from the periodic table. In the periodic table, when we move from left to right, the metallic character tends to become non-metallic. Okay, so they include both metals and non-metals, but when we are moving from left to right in the periodic table, we will lose the metallic character toward, and it will become gradually to non-metals. We'll find the non-metallic character as we move on gradually towards the right. From electrovalent as well as they form electrovalent as well as covalent compounds with non-metals. Okay, because they some the group 1, group 2 elements, even group 3 elements, they lose electrons. That's why they form ionic bonds. That is, these are electrovalent compounds they form. Even they form covalent compounds with the non-metals when they tend to accept electrons, and also they share electrons to form the covalent bonds, covalent compounds they form with the non-metals. Okay, the metallic nature increases down any of these groups. That is, when we move from the top to bottom, the metallic nature that increases. Okay, now group 1 and group 2 elements are metals existing in the solid state, and mostly they form the ionic bonds. And so they are good conductors as they are the metallic metals, and they form ionic bonds. So these are very good conductors of heat and electricity. Okay, they form basic oxides. That is, their oxides form alkalis when with water, soluble in water. They form alkalis. So they are colorless and soluble in water. They are very highly reactive, thus reacting violently with water and oxygen. Okay. Now, group 13 to group 17 elements are a combination of metals 13 to 17. So these elements are combination of metals, metalloids, and non-metals. They form ionic bond with metals and covalent bonds with non-metals. Then most of the non-metals exist in the gaseous state, but some of them also stay in the solid and the liquid state. Okay. Then non-metals of group 16 and 17. Group 16 and 17, the non-metals are poor conductors of heat and electricity. Okay, some heavier elements like tin and lead, they exhibit variable valencies. Okay, that is, they form isotopes. So they have variable valencies, or the tin and the lead. Okay. Next, we move on to the transition elements. See, these are the transition elements which are present in the periodic table. So this is the first group, which is known as representative elements. This is the second group, which is known as representative element. This is 13 group, 14, 15, 16, and 17. Okay, these are all representative elements. The in between, these are the yellow colored. The gray colored are the representative elements. The transition elements are between the two gray colored pillars on both the sides of the periodic table. Okay, so transition elements, or you can say transition metals, are those which have partially filled d orbitals. Okay, these are d block elements. Okay, so they have partially filled d block elements, and IUPAC, according to IUPAC definition, transition elements are elements having a d subshell that is partially filled with electrons or elements which have the ability to form stable cations with an incompletely filled d orbital. They form stable compounds, but their d orbital is incompletely filled, not totally filled. According to IUPAC definition is this one. Then they occupy the short columns in the center of the periodic table, that is between 2A and 3A. 2A and 3A. 2A is beryllium, magnesium, calcium, strontium, barium, radium. And 3A is boron, aluminium, gallium, then this I forgot the name. Then tellurium. This is NH, I forgot what is the name of this one. Okay, so this is the 3A group, boron family, and this is the alkaline earth metals. Between the alkaline earth metals and between the boron family, the elements which stay in the periodic table, those are known as transition elements. That is group number 3, 4, 5, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Then we come to 13, 14, 15, 16, 17, and 18. Okay. Now, next we move on to the characteristics of the transition elements. General characteristic, main characteristics you can say. They are typically metals. These transition elements are generally transition metals. Okay, these are typically metals because the number of electrons in the outermost shell is only 2. That is, they lose 2 electrons to form what? To form the octet. They are generally, frequently, they are paramagnetic. That is, they are attracted towards the magnet. They have a high charge and radius ratio. High charge by radius ratio. They have high density and they're very hard. Their boiling point and melting point are also very high. They have variable oxidation states. That is, they have variable valencies. They have variable valencies. Most of them, usually, they form colored compounds and ions. They create catalytically active compounds. Most of them are used as catalysts. Okay, catalytically they form active compounds. That is, most of them are used as catalysts. They create stable complex compounds. They create, but they are stable. Transition metals are hard, malleable, and ductile with the presence of strong metallic bonds. They form ionic bonds, I told you. So that's why their ionic bonds are so strong, their metallic bonds are so strong. That's why they form hard. These metals are hard, malleable, and ductile. Okay. Next, we move on to inner transition metals. What are inner transition? These are inner transition metals. The green colored box, which is just below the main periodic table. These are the inner transition metals. Now, what is the definition of this? These elements are those in which the last electron enters in the f orbital. They generally belong to the group 3 in the periodic table. They generally, so this is the La, this becomes lanthanide. Lanthanide group is this one, the upper one, and actinide is the thorium, this one group, the lower one. Okay, so these are the inner transition metals. They have their last electron enters the f orbital. They are f block elements. They have f orbitals have to be filled, incomplete f block elements. Okay, now they generally belong to the group 3 in the periodic table, but are mentioned in the f block elements. So also they are called f block elements. Okay. There are 2 series, that is lanthanide series and actinide series. In the last electron, if the last electron enters the 4f orbital, then it is the lanthanide series. And if the last electron enters the 5f orbital, then it is the actinide series. Okay, the inner transition metals are the elements where the f orbitals are filled. They have the incomplete f orbital. Next, the main characteristics of this f orbital, they are heavy metals they have high melting and boiling point. Okay, they have high melting and boiling point. They are heavy metals. Okay, and they show variable valencies. They have form colored ions. Actinides are all radioactive in nature. All actinides are radioactive in nature, and some are not found in the nature. They are prepared mainly in the special laboratory. Okay. Next, we move on to the noble gases. Okay, this is the noble gases. These are zero group. Okay, after 7A, this is the zero group. We find these are the noble gases. See, this is the 1A group. This is the 2A group. There's 1A is what? Alkali metals. What 2A is alkaline earth metals. Now 3B, 4B, 5B, 6B, 7B, 8 total. Sorry, these are the 7. Then 1B, 2B. Oh, these all are transition metals. Then 3A, 4A, 5A, 6A, and 7A, these are representative elements. And this zero group are the noble gases. Group number 18. They have fully filled electronic configuration. All the cells are fully filled. The valence shell is complete octet. Only helium. Helium has only 2 electrons in its valence shell, and that is also complete. Okay. So helium, neon, argon, krypton, xenon, and radon, these are the noble gases. Because they have filled valence shell, they are not reactive. That's why they are known as inert gases. Okay, they have stable electronic configuration. Okay, their group number 18 or zero group elements are gases which are chemically unreactive, meaning they don't form many compounds. Sorry, they don't form any compounds. So they are known as inert gases. Clear? Now move on to certain characteristics of these noble gases. Their electronic configuration, members of this group have 8 valence electrons, and that's why they have 8 electrons in their outermost orbit except helium because helium has 2. So they exhibit a stable octet configuration except helium, which exhibits a duplate configuration. The general configuration of the noble gas family is given as NH2NP6, where helium has only one S2. Okay. Atomic radii. The members of this group have very small atomic radii. Okay. Atomic radii of noble gases. Excuse me. Increases down the group with an increase in atomic number as the shell number of cells increases. Okay. When we move on from the top to bottom, the atomic radius that increases. That is the elements atomic radius, that is from the center to the outermost valence shell. So that radius increases because when the atomic number increases, the number of shells increases, and that increases the atomic radius. Okay. Ionization enthalpy. What is that ionization enthalpy? Ionization enthalpy is the heat which is required to form the ions of the gas, ions of the element. Okay. So no, that heat is known as ionization enthalpy. Now, the noble gases have 8 valence electrons, so they exhibit stable octet or duplate configuration. Therefore, this element exhibits very high ionization enthalpies because large amount of heat is required to ionize them. As they're very stable, you cannot, it's very difficult to separate the valence electrons from their stable configuration. So a large amount of heat is required to break that stable configuration. That's why their ionization enthalpies are very high. Okay. But as we move down the group, their atomic size increases. atomic radius increases, and therefore that decreases their ionization enthalpy. More close towards the nucleus, the ionization enthalpy will be more. But as the valence electrons, or valence shell is more away from the nucleus, that it is much more easier to break that stable configuration, and less amount of ionization enthalpy is required. Ionization heat is required. Okay, I think you are clear with that. Okay. So that will decrease. The more the atomic size, the less will be the ionization enthalpy. Okay, as we move on from top to bottom, their atomic size increases, the ionization heat also, or ionization enthalpy also decreases when we move on from top to bottom. That is inversely proportional. At the top, the ionization enthalpy is more, atomic size less. Less atomic size, ionization enthalpy is more. Up, that is. Okay. When we are moving down, the atomic size increases, ionization enthalpy comes down. Clear and clear? Now, electron gain therapy. Sorry, electron gain enthalpy. Okay. Here it is. In the previous point, it was to separate the electrons from the stable electronic configuration. Here, electron gain enthalpy, that is, heat is required to accept electrons in their valence shell. Okay. See, the members of this group, they have stable octet or duplet configuration. So, very large positive values of electron gain enthalpy is required. Why? Because you have to add an electron to the valence shell. It will not accept easily, no? So large amount of heat is required to give that electron to make it accept that electron. Here also much amount of heat is required to make it accept that electron, excess electron. So here also electron gain enthalpy is much more. Again, the same thing when you go this down the group, this atomic radius increases, so less amount of heat will be required to make that the element accept the electron. Less amount of heat will be required. Same thing according to the ionization enthalpy. Here also electron gain enthalpy will be up. The topmost element will have more electron gain enthalpy, and the least one will be, the lowermost will have least electron gain enthalpy. Clear? Now, next we move on to bridge elements. Now, what are bridge elements? Now, bridge elements are those elements of the second period of the periodic table. Bridge elements are the elements which are found in the second period of the periodic table. Now, why they are called bridge elements? Okay, we'll come across. These elements show a relationship with the third period element or the typical elements. Third period elements. Second period is bridge elements. Third period are typical elements. Okay. Now, they have a relation. These elements, the bridge elements and the typical elements, they have a relation between them because of the similarity in their properties. Because of their similarity in their properties, they have a relation between bridge and the typical elements. Therefore, they show similarities in their characteristics such as electronegativity and ion polarization. Electronegativity and ion polarization. Okay, they are diagonally related to each other. That is, see, you can see from the pictures. See, lithium has similar characteristics with magnesium, beryllium with aluminium, boron with silicon, carbon with phosphorus. Okay, so lithium and magnesium are bridge elements, beryllium and aluminium are bridge elements, boron and silicon are bridge elements. Okay, even carbon and phosphorus, these also are bridge elements. Okay. Now we come to, I told you, typical elements. The third group elements are typical elements. They are also representative elements. Typical elements are also known as representative elements because they represent the properties of their own group. That's why they are known as representative elements. Okay. The third period consists of 8 elements. That is sodium, magnesium. Third period, not group. Third period. Third period elements are known as typical elements. Clear? The second period elements of the periodic table, those are called bridge elements. The third period elements are known as typical elements or representative elements. Clear? Not group. Here we are talking about periods. Okay? That is in the row, not the vertical columns. Okay? Now, because they represent the properties of their own group, they are known as representative elements. The third period consists of how many elements? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The first two of these, that is sodium and magnesium, are S block elements, while the other of the members are P block of the periodic table. Sodium and magnesium are S block elements, whereas aluminium, silicon, phosphorus, sulfur, chlorine, and argon, these are P block elements. Okay. Now we come to see the periodicity of the periodic table. As we move on from the left to right, as we move on from the left to right of the periodic table, we see that ionization energy, that is ionization enthalpy, you can say, that increases from left to right. Okay. Electron affinity, that is attraction towards the electrons, gaining electrons, attraction of electrons, that to gain electrons, that increases while we move on from left to right. Okay. Atomic radius, that increases when we move on from top to bottom. See the arrows, just follow the arrows, that will help you in identifying the characteristics in the periodic table according to of the elements of the periodic table. Okay. Okay. Now, electron affinity, that is, it's an attraction of the element towards any electron to gain electron. That electron affinity, when you move from bottom to top, that increases from just opposite, from bottom to top, or you can say when we are moving from top to bottom, that increases. Sorry, that decreases. That electron affinity decreases as we move on from top to bottom. Even ionization energy also, when we move on from top to bottom, that decreases. Okay? Because the atomic size increases, the atomic radius increases, the valence electron, the valence shell is much more away from the center of the atom, that is from the nucleus. So therefore, the valence shell, the electron, the valence electron will be less attracted towards the nucleus. Therefore, it will lose electron very easily. Okay. Therefore, less energy is required to ionize that. Okay. That's why electron affinity is less, ionization energy is less as we move on from top to bottom. Atomic radius. Atomic radius, when we move from left to right, that decreases. Atomic radius, when we move from left to right, that atomic radius decreases. The metallic character. When we move from left to right, that decreases. That is, tends to get non-metallic character. The metallic character, that tends to lose its metallic character and tends to become non-metallic. Okay. Even the non-metallic character, that increases when we move from left to right in the periodic table, the non-metallic character increases. That is, it starts becoming non-metallic as we move on from left to right. Clear? This will help you in identifying the characteristics of the element. If you know the position of the element in the periodic table, you will easily identify its characteristics from this periodic table, from this periodicity of this periodic table. Okay. Now, what are the merits of the modern periodic table? It explains the periodicity of the properties of elements and relates them to their electronic configuration. This periodic table explains the periodicity of the properties, how often the characteristics are repeated, are almost similar in the periodic table, and how are they being relation between them with the electronic configuration, with their electronic configuration. The type of compounds formed by an element can be predicted by knowing the position of the periodic table, which is related to its electronic configuration. The type of compound by an element, what type of compound is being formed by the element, can be predicted. We can predict that what type of compound it is making. It can make by knowing its position in the periodic table, which is related to their electronic configuration. The classification of the elements also is based on the atomic number, which is a very fundamental property. Because modern periodic table is based on the character, that is the atomic number of the elements. The reason of placing the isotopes in one place is justified as classification is on the basis of atomic number. Classification is based on atomic number, and therefore the isotopes are placed in one place. That is justified. Okay. Then the lanthanides and actinides, they are placed separately at the bottom of the periodic table. Okay. Then the table is a simple, systematic, and easy way for remembering the properties of the various elements, which is based on the electronic configuration. Because it is based on the electronic configuration, though it's very easy and simple way and systematic way to remember them. And it is, we know that it is the atomic number is the fundamental property, and that is also based on the electronic configuration. The position of the position of the element, if we know it is in where it is present in the periodic table, we can predict what type of compound it can make. Okay, even the periodicity of the properties of the elements can be known because it can be related to their electronic configurations. Okay, now we come to the defects of the periodic table. What are the demerits of it? The position of hydrogen is uncertain because it should be placed, whether it should be placed in group 1A or in group 7. That is not confirmed because hydrogen has some properties like that. Okay, like the first group or the 7th group. Okay, there is no place of isotopes of the element in the modern periodic table. Though in one place, but there is no particular place for the isotopes. Then lanthanides and actinides, they are kept separately at the bottom. It is not present in the same periodic table, same table. Okay, under the table, okay, it is present. Now, the table does not explain the cause of periodicity and separation of the similar elements. Okay, some dissimilar elements are also placed together. Some dissimilar elements, we find them placed together. So these are the defects which are present in the modern periodic table. Okay, some other parts of this chapter is left. Some important metallic characters, some elements we need to discuss in this chapter. Furthermore, so these things are left of this chapter. We will discuss in my next video. Okay, till then, please do go through this. If you have any doubt, please do write in the comment box. You can please refer to my email ID, that is kasturi74@gmail.com or kasturi74@gmail.com. Okay, and if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet, please do subscribe to get the notification As soon as a new video is uploaded, please also ring the notification bell, because that will notify you as soon as the new video is uploaded. Okay. And so till then, please do meditate and continue with your studies. Thank you. Thank you for joining, and have a good day. And you will find in the description box the links of the previous videos of this chapter, as well as the links of the other subjects, that is physics, chemistry, and biology, also in the playlist links of this video. You can just navigate to those links and find your chapter which you want to study. Okay. Thank you. Thank you for joining. Have a good day.